This is how air conditioners are made to withstand the harshest heat waves. In an age where heat breaks all limits, turning cities into open ovens, one device stands against this inferno, turning scorching breath into a cool, refreshing breeze. It's the air conditioner. But have you ever thought that behind this quiet cooling lies a complex engineering battle? And that every cold breeze brushing your forehead was preceded by thousands of processes inside massive, precise factories? In this video, we take you on an engineering adventure deep inside one of the largest air conditioner factories in the world, where aluminum and copper sheets are transformed into a silent shield against the summer blaze, and commands flow from the minds of engineers to robotic arms that don't make mistakes.
We'll follow this device from the very moment it was born as raw metal
Until it stood proudly in your room, delivering coolness and pushing out the heat. Not only that, we'll also dive inside the heart of the air conditioner to understand how heat becomes breeze and noise turns into comfort, thanks to design brilliance and precision execution. How an air conditioner works, simply explained. An air conditioner relies on a closed cooling cycle that transfers heat from inside the room to the outside. The compressor begins by compressing the refrigerant gas, raising its pressure and temperature, then passes the hot gas through the condenser, outdoor unit, where it releases heat and turns into a liquid. Then, the liquid passes through the expansion valve, which drops its pressure and cools it significantly, before entering the evaporator, indoor unit. There, the cold liquid absorbs heat from the room air and evaporates again. The internal fan blows air over the evaporator to cool it, while the cycle repeats continuously. Every part of this cycle is precisely designed to reduce loss and enhance cooling efficiency, from the type of gas to pipe and fan design down to smart sensors that regulate performance automatically. Stage 1. Manufacturing the outer shell. The manufacturing journey begins with galvanized aluminum sheets cut and shaped automatically to form the AC's outer casing. The sheets are coated with a layer resistant to rust and moisture. At this stage, ventilation holes, corners, and curves are added with precision. Stage 2. Compressor manufacturing. The beating heart of the AC. It is made inside sterile rooms where pressure chambers, valves, and coils are assembled. Each pressure unit is tested individually to ensure maximum efficiency at high temperatures. The compressor is responsible for compressing the refrigerant and moving it through the system, and any slight change affects the unit's efficiency and energy consumption. Stage 3. Internal cooling system. Thin copper tubes are formed to carry the refrigerant gas. These tubes are welded with precise heat without damaging components. The tubes are wrapped around aluminum fins to increase heat exchange area. The secret? Using eco-friendly refrigerants like R32, which offer faster cooling and lower energy consumption. Stage 4. Smart control unit. Here, the brain of the air conditioner is added. Precise electronic circuits are designed to control temperature, timer, sensors, various cooling modes, and even smartphone connectivity. The control board is programmed to save energy when no movement is detected in the room. Stage 5. Blower and distribution fans. The fan blades are made from reinforced plastic or aluminum. They are tested for vibration resistance and noise levels. The fan is responsible for pushing cold air into the room and distributing it evenly. Stage 6. Thermal testing. After assembling all components, the air conditioner enters the desert simulation chamber. It is tested under temperatures exceeding 50 degrees Celsius. Cooling speed, power consumption, and performance stability during continuous operation are measured. Stage 7. Packaging and distribution. The air conditioner is packed in moisture-resistant cardboard boxes. Shock-absorbing materials are placed inside the box to protect it during shipping. Specification and energy efficiency labels are affixed. Then it is transported to distribution warehouses. How does an air conditioner work? Imagine the air conditioner as a magician. It doesn't create cold from nothing, it simply takes heat from the space and expels it outside. The secret lies in what's known as the vapor compression refrigeration cycle, a closed loop of precise components working in perfect harmony to produce this amazing effect. 1. Compressor. The starting point. This is where everything begins. The compressor acts like a beating heart, pulling refrigerant gas from the evaporator and compressing it, raising its temperature and turning it into a high-pressure, high-temperature gas. This high pressure is necessary to push the gas through the rest of the cooling cycle. 2. Condenser. After exiting the compressor, the hot gas flows through coiled pipes in an outdoor unit known as the condenser. Here, powerful fans cool the gas, causing it to condense into a warm liquid, like turning hot steam into water. During this stage, the heat is expelled into the outdoor air. 3. Expansion valve. Now comes the physical paradox. When the warm liquid passes through the expansion valve, its pressure suddenly drops, drastically lowering its temperature. This is the moment it becomes a cold mixture of liquid and gas, ready to absorb heat from your room. 4. Evaporator. This is the magical spot inside the room. The evaporator pipes carry this cold liquid, and heat from the surrounding air is absorbed through metal fins that speed up heat exchange. The resulting cold air is pushed into your room by an internal fan, while the resulting gas returns to the compressor and the cycle begins again. 5. Control and integration. All of this is monitored by an electronic control unit that oversees temperature, fan speed, and operation modes to ensure maximum comfort with minimal energy use. The result? Fast, smart, and safe cooling, all in a never-ending cycle, operating silently, turning summer heat into a cool breeze. The air conditioner in the economic balance. Air conditioners are no longer just household devices, they are now part of the infrastructure of any productive or industrial environment. From offices to hospitals, factories to data centers, effective cooling means a stable work environment, higher productivity, and fewer breakdowns. Estimates show that global AC factories produce over 150 million units annually, and the global air conditioning market is expected to surpass $220 billion by 2030. Inverter technology has helped reduce energy consumption by up to 40%, making air conditioners more eco-friendly and operationally efficient. China, Korea, and Japan lead global AC production, while Arab markets, especially the Gulf, are seeing rapid growth in demand driven by rising temperatures and urban expansion. Remarkably, air conditioners are no longer a luxury. They've become a critical factor in improving quality of life and work, increasing productivity, and providing suitable environments for both machines and people. Behind every press of the on button on your AC is an army of engineers, designers, and technicians. Air conditioner manufacturing isn't a luxury, it's salvation from thermal hell. If you enjoyed this type of video, don't forget to subscribe to the channel and turn on the notification bell.